Here we go, guys. So we're going to finish this up together today, and then I'm going to give you an assignment for you to work on your own that will sort of serve as a practice test, okay? All right, so now we are taking the logs and combining them into one, okay? So the thing that you have to remember, if you're doing anything with your notes, is addition is the same as what?
Multiplication.
Multiplication. And subtraction is the same as division. And multiplication is the same as what?
Addition.
What?
Addition.
No?
Exponential.
Yeah, exponent. Multiplication is the same as an exponent. So what I mean by that is if you have 3 log x, you can write that as log x to the third. Those two things are the same. Everything okay? No?
So multiply is the same as
Raging?
exponent?
Yeah.
What's subtraction? I mean, what's division as?
Well, if you go the other way, division is the same as subtraction. So if you have
But that's just somewhere.
if you have log of x divided by y, you can rewrite that as log of x minus the log of y.
But it doesn't work that way with multiplication.
Yeah, if you have
Now what's the whole multiplication thing?
multiplication and addition are the
No,
same.
third one down.
Oh, okay. This is if you are. This side is what you're doing to the logs, and this is like when you have multiple. We'll do some examples, and then you'll be like, oh, okay, I totally get this. Okay. All right. So number 38. Easy one.
24?
No?
Yes. Absolutely correct. Log of 24. Okay? Because 8 times 3 is 24. Okay? Number 39.
Subtraction.
It's log.
5/3.
5/3.
Log base 2 of 5/3. Because subtraction is the same as division. Okay? All right, so number 40, so yes.
And like you said, those bases will always be the same.
Yeah, if they're not the same, you can't combine them. Okay? What do you got going with your phone there? Okay. Can you put that away? That's not away enough for me. That's just going to come back out. No, like, do you have a backpack or something? Give it to, what's her name? She'll put it in the desk drawer for you. You guys can't resist that temptation. James, did I answer your question?
Yes, you can solve the problem.
Right, so if they're different logs, then you can't do it. And so you'll notice that they're pretty much always going to give you the same answer. Okay? All right, so this one right here, the multiplication in front becomes what?
Exponent.
An exponent. So the first thing I'm going to do is I'm going to rewrite this as log base 3 of x to the 4th plus log base 3 of 7.
Yep.
And then the addition becomes
Multiplication.
multiplication, so it's log base 3 of 7 x to the 4th.
Now, that 4th isn't to the 7 either. That's not to the 7 too,
No,
is it?
because the 4 was only in front of the x.
So would
thing.
you have to parenthesis?
No, parenthesis would mean it would be the both.
No, just around the x.
Oh, yeah, you can do that, but if it's just after the x, that pretty much says the same thing. Okay, we can do that if that makes you happy. James? Say that one more time.
X on log of x and then minus log of y, or base x and y times.
Right, because it doesn't say a base, so it's base 10, yeah. Okay, so,
They are two different variables, so I was wondering if you could do that.
well, what's the, we're going to still have variables in our answer, but what is subtraction, just like we did with number 39, what does the subtraction turn into? Division. So this is going to be log base 10 of x divided by y, like that. Okay? All right, how about 42? What do we need to do with the 2?
Exponent.
Make it an exponent. So the first thing I'm going to do is I'm going to change it to log 5 minus log of x squared. And then I'm going to change it into division, yeah. So final answer, log 5 over x squared. Okay? And then 43, I'm going to freak you out. I'm going to do it in one step.
Easy.
I think I know what you're gonna do.
Log base 4, x cubed. Oh, I lied. Because they're both x's. So what can I do with x to the third and the x squared? What does that combine to be?
X.
X to the fifth.
Why didn't you do that one step to begin with?
Say again?
Why didn't you just do that?
Because I thought it was going to be like an x and a y, like these things right here. I didn't realize they're both x's, so there was one little thing. So, yeah, I got called out there.
Try to,
Reed even said, prove it.
try to show off, you failed.
I know, right?
So that's why I always say that, just to so
Yeah.
lie to you.
Yeah, sorry, I lied to you.
Because I wouldn't know when you're lying.
Let him fail.
Okay. Okay, now we are then going to go the other way. Okay,
Easy.
let's do this.
Log base 4. 2 log.
So, 44, since this is multiplication, I'm going to expand it out to addition, and I can also at the same time put the exponents down in front. So 2 log base 4 of x plus 3 log base 4 of y.
I got that.
You got that?
I got that.
No, they just want you to expand it out.
That is solved.
Right, that is the answer. Okay? 45. Fasten your seatbelts. Are you ready?
Easy.
Log 4 plus 4 log s plus log t.
Oh.
So basically, I already.
Okay, 46. Now we've got division. So what do we do with that? We get subtraction, so it's going to be log base 3 of 2 minus log base 3 of x.
See, it's like the steps right after these steps that are just, I'm pretty sure. I'm just gonna be honest.
Whoa.
Okay, 47. 2 log x plus 3. Done. Done. If it was log of x plus log of 3, 2 logs being added together, you could make it into multiplication, but it's already a single log, so we can't make the addition into multiplication. And that's it. Done. Don't overthink it. Don't overthink it.
I'm not gonna overthink it. I'm not gonna overthink it.
Okay.
So when it's grouped together, that's a single.
Okay, 48, same deal. Looks like there's a lot that you can do with it. But there's not. Put the 3 in front. Log base 2. 2y minus 4. Okay? Alright, and then the last one, number 49.
Dips.
Okay?
2 log z
Yes.
minus log 5.
Okay, do you remember the change of base formula? Which you can use, so like number 50 is saying 2 to the what power is 7? And who knows, right?
No
Because
one.
2 squared is 4, 2 to the third is 8, so somewhere between 2 and 3, so you don't know, but you'd like to figure it out. So on your calculator you go log 7 divided by log 2. Remember that? Oh, I proved it.
Yeah, but I don't, I was like,
Yeah.
By log 2.
What is on?
2.8.
Yeah, would you?
Wait, Josh, we're gonna use this as notes.
Downstairs stairwell, what?
We're gonna use this as notes now. Okay.
That'll prove your basketball game.
what is it equal?
What does it equal? Who's got it?
2.8.
So you can only
2.81?
Sure.
So that's basically a calculator question.
For sure, yeah.
So you do the
What
same.
did you get, Tony? Did you close the parentheses when you did log 7?
I did.
Okay, close your parentheses.
Oh, so that's it.
I did.
Okay, 51, what would I type in the calculator? Good, log 10, close the parentheses, divided by log 3.
So the 10 the bigger number always goes first?
Yeah.
What if the base is bigger?
Doesn't matter, it's the bigger number like in font size.
Is that equal?
Big.
This is like size small.
Yeah, let's sort of appreciate that.
How's that 2?
Oh, wait, no, I can't make it.
Okay, so now we are going to solve some equations using this, okay? And so again, the key is when you see a variable in the exponent, that means you need to solve it by logging both sides. So I'm going to start by going log 25 to the 2x equals log 125. Okay? Why did I do that?
Because you gotta solve it.
And so how does that help me solve it?
Well, can it, how do
Don't answer, Cameron. Right, so I can put the exponent in front. So I can rewrite this as 2x log 25 equals log 125. Alright? So what do I do next? Good, get rid of the logs first because they're stupid and nobody likes them anyways. Because people make mistakes with parentheses. I mean, you could do that. What do you get?
2 to the 5th?
Huh?
Wait, what?
Log
Oh, I have
125?
to plug it in. That's stupid. I
Yeah, yeah.
forgot about all that.
So what do you get? 0.75. Oh, 1.5, yeah. Final answer, 0.75. Okay?
Oh, God, I'm gonna miss every one of those questions.
Where things would solve for you?
Well, this is like, I can see, like, when we do a review, where I'm gonna go to the test, and be like, oh, alright.
Yep.
Might as well.
Yeah, every time.
What'd you say, Jacob?
Log 3x equals log 36.
Okay. Log 3 to the x equals log 36.
What was that?
Put the x in front.
See, I'm gonna forget all this. So I don't even know how. I got short term. I think.
And then we divide by 3.
Yep, divided by log of 3. So, I don't know, write it down.
I am.
Okay.
This time I'm gonna try to change my strategy.
See how that works. And then log 36 divided by log of 3 is 3.26.
See how rough college actually is with the numbers.
3.26.
3.26.
Log 3.26.
Yeah.
Okay? Can I make that go away?
No.
You will? Where will I go?
You?
Because we could, I would be okay with that, depending on where I show up.
We'll take you to Maui.
Okay. Actually, you make me go.
Serious?
Already? Go back! Not there yet, go! Okay, 54.
I need a calculator. Here we
What
go.
do I do first?
Log of x minus 3
Log
log
both
of
sides.
7.
Stop.
Let's get her done.
Log 7 to the x minus 3 equals log of 25 with the exponent in front. X minus 3 log 7 equals log 25.
Divide that.
Divide both sides by log of 7. X minus 3 equals 1.65. Nice. What do I do with the minus 3? What? Got it. So final answer, 4.65.
Alright, see, I feel like I get it, I just.
I feel good about what's going to happen.
Hey, they already crossed out my
I
name.
just don't. I just don't.
No.
Okay, what do I do first here?
Log it.
Not yet.
No, I don't know. You, minus 3.
Minus 3.
Basic algebra.
Basic algebra, come on. So 5 to the x equals 9.
Log it.
Then log it. Yeah. That's retarded.
I agree.
Then what? Yeah.
Exponent in front.
Remember campfires. Then what?
Exponent in front.
Exponent in front.
What decimal place do you want us to go to? Where
It says 10,000. Didn't notice that.
1.3.
Tens, hundreds, thousands, 10,000, 4 decimals. So what'd you get?
1.3652.
1.3652.
Because that's what they want.
Okay? So, again, moral of the story, when you see a variable in the exponent, solve it by logging both sides.
Hold on. Let me write down the original problem. So I
Yeah.
see
Okay.
instantly
Instantly, yeah, this, but you shouldn't be, because remember yesterday when we did those problems where it was all about rewriting it
Yep.
in log form or whatever? And I said, this is the secret to life, the universe, and everything. Okay, this is why I said this. Because, what's my base right here?
10.
10. So what this is saying is, this number, the base number, to this power equals this number right here. That's
10
all
to
it
the
is.
first power.
Okay, so 10 to the first equals 3x.
Okay.
So you divide
10
both sides by
equals
3, and x equals 3.3 repeated. That's all it is. That number to that power equals that.
equals 3.
3x.
Let me do the next one.
Okay, so 57, you would rewrite it as 4x equals 2 to the 5th. This number to this power equals this number right here.
Wait.
Because that's what log means. Log means take this number, raise it to this power, and set it equal to that. Okay? 2 to the 5th.
It'd be 8.
Right? So, rewind a little bit. Go back to the last one.
Okay? So this didn't have a base, so
You
it's
got to
10.
put a 10 to the first.
So this number
to the
to
first.
this power equals this.
I know that.
Okay.
Equals 3x.
So that gave me this little equation, 10 to the first equals 3x. Well, 10 to the first is just 10, right?
Yeah.
So I just divided 10 by 3 and got my answer.
Always wakes me up.
Good check, nah.
Yeah, right.
All right, now 58.
This is hard.
Yeah, this is a challenge, okay? Because you got logs on both sides. So
They're not
you
the
can be legitimately frustrated by that, yeah. What's that? Because this has an x and this has a 2x squared, if they were the same. Hey, I don't care if you don't want to pay attention. I mean, I do care, but that's your choice. But don't be so loud that the people that are sitting around you can't even understand what's going on, okay? What? I am going to end up dividing them. Yes, that's absolutely correct. So I'm going to take log x equals log 2x squared minus 2. And I'm going to subtract log 2x squared from both sides. Okay, solving for x. And that might seem wacky, but that's what you always do when you're solving equations. If you have an x on both sides, you subtract these x's to get them over there, right? So I have x's on both sides, so I'm going to subtract these x's to get them over there. Okay? The nice thing is, when I'm subtracting logs, what does that become? Division. So when I go log x minus log 2x squared, that becomes log x over 2x squared. Okay?
How's that? No.
Yeah, probably not. This is, on the challenging side of the stuff that we've done. So if you can stay with it, then awesome. Yeah. You
Like
might
they're writing it down.
-2.
Okay, so what'd you say? So x over 2x squared equals 10 to the -2, because once I get it down to a single log expression, which is why we practice doing that in the first place, I can use the definition of a logarithm to rewrite it as an exponential function. Okay?
So it's
Point
Negative,
0.01.
no, it's 1 over 100.
Oh, yeah.
Okay.
But why? Why?
So x over 2x squared equals 1 over 100, right?
Why?
Okay, so I'm going to cross multiply. So 100x equals 2x squared.
What?
What? I just cross multiplied.
Okay.
Okay,
No.
now what? Divide by 2. So x squared equals 50x. But I got an x over here still. Well, so that means if I square rooted both sides, I would end up with the square root of x in there, which is a bad deal. Divide by x. And what's x squared divided by x? X. So x equals 50. And I'm done.
Wow.
Yeah, that's a tough one. That's a challenging problem, for sure.
So,
So if there's any ones that you're going to let go of, this would be one. Okay? When you have logs on both sides, you might just look at that and say, hey, I'm just going to guess x equals 2. I don't know. We'll see what the test is.
what'd you do with the, okay, your very last
Might not
step?
even be one on.
You should make an extra.
Very last step, you divide. Your very
Yeah, last step I divided by x, and then since x squared over x is x equals 50.
So how is it gonna be that convenient?
No.
How is it gonna be that convenient?
Okay, let's try number 59, which is not nearly as difficult. Yes.
Work on your shirts.
Hey guys. What? 10 to the -2 is 1 over 100. Okay. Okay, 59. 2 log base 3 of x equals 54. So how do I get rid of the 2?
Goes next one.
I could put it as an exponent.
Divide by 2.
It's easier to divide both sides by 2.
Yep.
So log base 3 of x equals 27.
So 3 to the 27th power.
So 3 to the 27th power equals x. And I'm just going to leave it like that because 3 to the 27th would be too large of a number to even fit into calculus. Okay?
7.625597485 e to the 12th.
So times 10 to the 12.
What's 327?
3 times 3 times 3 times 3 times 3 times 3 times 3.
Squire. 625.55. Yep.
What do you call it? You call it R, B to R.
Solve by
B
graphing.
to R.
Hey,
Is it R? You use the letter R, right?
for what?
B to the R equals.
Oh, b to the x equals what? That's what you're going for?
Yeah. What do you say?
Okay, I don't want to do
Can we use the self test?
the notes that we're doing right now. Yeah, I don't want to solve by graphing, so I'm going to skip 60 through 63.
Yeah.
Okay, that's just calculator junk. All right, let's do some word problems to wrap it up here. Okay, so this says a culture of 10 bacteria started. So I'm going to go y equals 10 times the number of bacteria will double every hour. So 2 to the x. Okay, if it was every 5 hours, I would have to go x over 5. Okay, if it was every 12 hours, I'd have to go x over 12. But since it says every hour, I'm just leaving that as x. Okay, so that's my equation for that. And about how many hours will there be 3 million bacteria? Where does the 3 million go? And for the y. So 1, 2, 3, 4, 5, 6 equals 10 times 2 to the x. So what do I do to solve? Not yet. Not yet.
Divide 10.
Divide by 10.
by 10. Yeah.
So that
Take out
cancels.
the 0.
Yeah, 3 million divided by 10 is going to be 300,000. And now, I can log it. So log of 1, 2, 3, 4, 5 zeros equals log 2 to the x. Yes. What? If I do the same thing to both sides, I can throw whatever I want in there.
Yeah, why wouldn't you just make it simple and
Divide by 2.
divide by 2?
Because it's not 2 times x, it's 2 to the x power.
When it's to the power.
So dividing by 2 is not the inverse of raising it to the x power.
Why does it look like 2?
It is 2 to the x power, it's not 2 times x. So what you're saying, if you divide by 2, that would be if it's 2 times x, but it's not. It's 2 to the x. Okay? So I don't have an inverse operation for to the x power, so that's why I do the log. So anytime you have a variable as an exponent, that's when you do the log. Okay? Because now what can I do with the x?
Bring it down.
Bring it down in front, and now, James, when I bring that down in the front, now I do have multiplication. So what can I do to get rid of this log of 2? Divided by log of 2. So when you're here and you say, don't you just divide by 2, you divide by log of 2. Okay?
18.1946.
So x equals 18 point what?
1946.
1946. Okay? So in just over 18 hours, there would be 3 million bacteria.
That's cute.
Okay, can you please stop, Matt? Like for the rest of the period, stop. And maybe for the rest of the year, even. Since you're not 12.
I think Ben just needs to direct it.
You think what?
If Ben just directs it.
I give him permission.
I give
I give him permission, or he gives him permission.
I'll prove it. It's so long.
All right, number 65. When you see E, you think natural log. Okay, A plus for Miranda, she doesn't have to take the test. When you see E, you think natural log, okay? Natural log and E go together just like log and base 10 go together. So to get rid of this E, I am going to take the natural log of both sides.
So it's natural log E.
Right. So technically what I'm doing is I'm putting the 3x in front and making it multiplication, and then the natural log and the E will cancel. So I'm left with 3x equals the natural log of 12. Okay? Because I'm 100% sure I've explained this before, but I will again, because the base of natural log is E. So this is saying E to the what power equals E. And that answer is 1. So I just cancel that out because it's just a 1. James?
So log and natural log is different.
No. They're very, very similar. Natural log is a specific type of log that always has base E. Okay?
It's not a base in all.
So you can say log base 2 of x, James. You can say log base 5 of x. You can say log base 10 of x, and when you do that, we say we don't need the 10. And you can say log base E of x. But when you do that, because it happens so often in real life, they gave this a special name. Okay?
Is that the end of the answer though?
Okay?
No,
No.
I got it.
All right? Okay, how do I get the x by itself?
We got
Yeah, but how did an x
divide by 3.
become not an x?
I thought,
When you log both sides, that's what happens. The
Oh, yeah.
exponent comes in front, yeah. Okay, so it's going to be natural log of 12 divided by 3, which is 4?
It's
No.
0.83. 0.838. 0.83.
Natural log of 12, Miranda, close the parentheses. Okay, now you have to take the test. George, what'd you get? 0.829, thank you. Okay, so the moral of this story is when you see natural log, think of E. When you see E, think of natural log, and all the other rules are the same. Okay? Natural log is just a specific case of logs. Case of logs. All right, natural log of x plus natural log of x plus 1. What can I do since we're doing addition?
Multiply.
Change it into multiplication. So natural log of x times x plus 1 equals 2. Okay?
yeah.
Log is the inverse of x to the one. Meaning the base number is about whatever it equals. Equals a thing. Okay, so this is what a log means. This number, this power equals this right. So E squared equals that.
Wait.
There's like,
This
Okay.
number to this power, that's the E squared, equals that.
Oh, okay. So you just put the E, so the base of natural log is E.
Yeah. Got it? Okay. Now I need to distribute the x. So E squared equals x squared plus x. Okay? This is where things get a little bit dicey because you guys are not really very good at solving quadratics. You want to like square root both sides or whatever we did before. I'm going to get everything equal to 0 by subtracting the E squared. And then I would use the quadratic formula. Okay?
what you added.
Let's just call it good right there.
I
Okay?
like trying so, let me just catch up to your level.
With those as my things, A is 1, B is 1, and C is negative E squared. And since some of you have that on your calculators, you can just type that in and then get the answer like that.
So if I just left it like x2 plus x minus 2 equals 0. If I got that far, would it count it?
Yes. All right, 67. Just like with the, other ones, we need to start by combining this into a single log before we apply the definition of logs. So 2 natural log of x is really natural log of
X squared.
x squared, plus 3 natural log of 2 is really natural log of 2 to the third
Oh, okay.
equals 5. Okay, yes.
So there's sometimes we'll have that and we'll take the 2 and bring it down in front of the log.
Right, that's if it's a variable.
I don't get when to do that.
Okay, if it's a variable in the exponent like this one, that's when you bring it down in front. Okay, but these are not variables, so that means I have to do the other way around. Right? Yes, so we're going to combine those two because addition is the same as multiplication. Also, 2 to the third equals what? 8. So this really simplifies to the natural log of 8x squared equals 5. Okay? And then now I can use the definition of logs. This number to this power equals this number right here. So 8x squared equals e to the 5th. Okay? How do I solve that for x? 2 steps.
Divided by 8.
Divide by 8. Yep. McGuire would really be a lot happier if we solved that for e. He doesn't
148.
like that e to the 5th.
But we know what it is.
Right. So, and then my second step, my last step is
Let's say
square root it. Yeah, so x equals the square root of e to the 5th over 8,
I got 4 for
Oh, yeah.
4.3.
That is a disgusting problem. It's just ugly.
easier than
All it is.
Yeah, true. I agree with you there. Okay? All right.
How many, okay, so hold on, how many problems are there?
No,
Do
this
the
is
last one.
Second to last page here. James? Okay, I'll slow it down. Matt and Jed, we'll go into the hallway. I don't want you in here anymore. You're just being a distraction. I'm tired of telling you to be quiet. It's like helping people and all that. Just go outside and wrestle or whatever you guys really want to do.
Yeah.
Yeah, take your time out. All right, so with number 68, so we're going to go slow. Subtraction, James, is the same as division. So my first step is to rewrite it as natural log of 4 divided by x equals 2. Okay? Does that make sense? Okay, right. Now that I have it condensed down into a single natural log, I'm going to use the definition of logs to rewrite it as an exponential problem. 4 over x equals e squared. Okay? This number to this power equals this.
Oh, you get rid of the log once you do that?
Yep. What?
You made it e to the second power.
Right.
So that's what you like you took the number and then you got rid of the ln and put e there.
Yep. Yep. That's what we're always doing with natural log. Okay. Okay. How do I solve this?
Times by
Not times by 4 because 4 is on the top.
going to times by
Times
x.
by x. Okay. If I multiply both sides by x, that gives me 4 equals e squared x. And then how do I get rid of the e squared?
Put it in the calculator.
Divide each side by e squared. Bugs McGuire also, and I'm not solving it because I don't have a calculator. So it's e squared. Okay, so what's 4 divided by that? 0.54? No, not if what he said is true.
That's like 4 divided by e squared.
Right?
What did you say, 7.38?
0.54. Oh, yeah.
Yeah,
0.542.
No, you're right. I was going the other way. All right, number 69. What do I do first to get rid of the 4? Divide both sides by 4. So e to the x minus 1 equals, what's 64 divided by 4? 16.
natural log.
Okay, natural log both sides. So natural log of e to the x minus 1 equals a natural log of 16.
That cancels out.
The natural log and the e cancel. So x minus 1 equals natural log of 16. Add 1 to both sides, so natural log of 16 plus 1, which is
Wait a minute.
final answer with the plus 1. Did you close the parentheses on the 16?
Well, I get it.
3.7.
Wait,
7.
Read.
so, with the ln natural log of e up there, so, how can the base have an exponent?
Oh, well, the base, you mean because e is a base of a natural log?
Yeah, I know your natural log.
But the bases of these things are always numbers, and you can make them, give them exponents anytime you want. So
but
like
that
log
is-
has a base 10, and I can say 10 squared, I can make 10 a base and do an exponent. That's no big deal. It's all
Yeah,
good.
but you,
Gets a little wobbly.
where'd you put the ln e, the natural log of e? Where'd you put
They
that?
cancel, natural log of e cancels out. They're inverses of each other.
Yeah, exactly.
So they whoop, go away.
Yeah, but you can just bring the exponent down to like a normal thing now.
What I'm really technically doing, I had this discussion with Luke the other day, is I'm using that
Oh, so you
property.
bring it down.
Right, and then they
We just
cancel.
kinda
I just skip
fast
that, yeah, exactly. This is why
Okay.
you write that, James?
So every time the equation starts with the
Uh-huh,
you take out the ln.
Correct.
And then you do vice versa on the.
right, so
ln.
number 70 has a natural log, so we're making it e. Yeah, okay?
Hold on, don't fix the screen now. Because I need to write down.
70. Like James said, this time we have natural logs, so we're gonna be an e. Okay, but before I do that, I have to combine it into one single natural log. And that would be natural log of 5x cubed. Because the 3 becomes an exponent and addition becomes multiplication.
This one's.
Okay, so now, one way that you could think of this, and this isn't necessarily mathematically correct, is that I'm gonna e both sides. So the e and the natural log cancel. Then 5x cubed equals e to the 7. Okay? That's what you're doing when you're saying this number to this power equals this thing right here.
Okay, you can get, go e to the seventh right now.
Yeah, e to the 7th right now, then divide it by 5, take the cube root, and you're done. Yes?
Could we put the exponent of 3 in front of that ln or repeat it?
No.
I just tried, it
No.
doesn't work.
Yeah, it doesn't. You need to have this, has to be starting with the natural log in order to do the e thing. You can't have any numbers in front.
Well, how can we do that with the?
When did I do it the other one? Lies! I never did that.
Yeah,
So, final answer?
Huh?
How can we put that in front of this?
Because the e didn't have anything in front of it, it was just an e. So
So
it's the same thing, the natural log can't have anything in front of it. So that's why our first step was divide by 4. Because I can't have anything in front of the e when I'm natural log. Okay?
Final answer.
All right, last one.
Never mind.
Hold on. We gotta get the final answer here, so e to the 7 equals e4.
X
2.84?
equals e to the 4.
Divided by 5. How do you cube root on it?
You can hit the little exponent button and go 1/3.
But isn't that just e to the 4? Right? Practice? No.
Where's the exponent?
I don't know what you're talking
The
about.
little roof. You got it wrong, George?
Yeah,
Oh.
something like that.
So, I need your help.
What'd you get?
The calculator.
6.03. Okay, last one. Since this one says continuous compounding, that's your clue that you are using
Apron.
E. Yep, A equals PERT. Okay, so an initial investment of $350 is worth $429.20 after 6 years of continuous compounding. So 429.20 equals 350 E to the, I don't know the interest rate, but I know the time is 6, so it's going to be 6R. Okay, and this time we have to solve it for R. James?
Isn't there another equation that's like I equals B R, like the interest one, we had back in like algebra 1?
Yeah, it's this one. E times e to the R t.
That one.
It's the same one.
Same thing.
Same thing.
But we didn't have an E right?
Yeah, you did. In algebra? Yep. That's when you first see this. I can show it to you in the book. You don't believe.
And why was it so easy back then and now it's like?
Solving for R.
Because this time we're solving for R. Back then we were just trying to figure out what this was.
No, we're trying to figure out the time too.
Oh,
Sometimes.
I don't know.
Maybe.
Maybe life was just simple then.
Maybe it was.
Okay. What do I do to solve this for R?
Log it.
Nope.
Divide.
Divide.
I always forget that part. That's
Divide by 350 first.
I'm gonna forget it.
Okay. What's 429.2 divided by 350? 1.23. So e to the 6r equals 1.23. Okay. When you see an e, what do? You natural log both sides. Okay. So natural log and the e cancel. 6r equals natural log of 1.23. Divide both sides by 6 and you're done. Okay? All right.
Hey.
Divide by what?
Hi.
Okay, here's what's going to go down tomorrow. This is important that you pay attention and understand because this is different than what we have done before. Your assignment is page 491. 1 through 18. Okay? Page 491, 1 through 18. When you come in tomorrow, the first thing I am going to tell you to do is to trade your papers with someone else and we will correct them. There will be no time for questions before you get your grade on this assignment. Okay? So get it done before you get into class. Then we will give them back. You can see how you did, and I will go over your questions from the ones that you got wrong.
What was the
Okay?
answer? I need this idea.
Do it, Jen.